Yeah, hello. Good evening. Thanks a lot for having me. I'm very happy to be here at this wonderful lecture series. And I want to invite you to reflect with me today on how computational processes are integrated in music composition. As we know from kind of the history, non-musical processes have been source of inspiration for composers throughout the centuries. Hereby, various kinds of processes have been integrated to help the composers either carry out or their compositional ideas, or maybe also gain some ideas. When we think of the 20th century, especially concepts such as chance operations or numeric systems appear very prominent. For example, serial processes, statistic behaviors, maybe L systems, growth systems. The possibility to integrate these approaches emerged in close relationship with the development of digital technologies. This, on the one hand, enables the composer to hand over calculation processes to digital devices, but on the other hand, it also leads to new constellations within this kind of interaction between composer and technology, especially as technology sometimes seem to take over a large part of the creation, a challenge that is widely discussed in music research and that most of you probably have heard of latest in the beginning of this year when we had first deep fake music productions on Spotify. Here, especially the challenges and risks for music and music practitioners have been pointed out, coming along with a lot of rather dystopian visions and ascriptions to automatic music productions. But what does it practically mean to embed complex algorithms such as generative systems in music composition? And is the implementation of these seemingly automatic processes really that new? I want to look at this with you today by various processes, and I want to start in a way from this idea of computer-aided composition, and then we walk our way towards a bit more automatic approaches. Let's start with some very general approaches, and I don't know how much you heard about it, but I want to start with some definitions. Doesn't want to. The term computer music was defined in the 1990s, amongst others, by Martin Supper. He describes in 1997 that under the umbrella of computer music, we understand music where the computer is a significant part in the creation process. And hereby he also refers to algorithmic composition and hence implicitly places computer music in the tradition of serial music, even though not mentioning a specific style or genre. In 2010, Nicholas Collins detaches this definition from the compositional approaches and explicitly focuses on the technical aspects as fundamental. Namely, and I quote, computer music could be most generally defined as music that involves a computer at any stage of its life cycle, end of quote, and he explicitly refers to microprocessors. That, in a way, defines the music by technology, but it excludes it also by technology. So we don't have unplugged music, we don't have amplified elements, and we also don't have non-microprocessing in computational processes. Though the definition of super helps us a bit more to understand maybe why before we had the term computer music, this kind of music was also entitled automatic composition. A term that, following Adam Alper in 1995, was used for the process of using some formal process to make music with minimal human intervention. Already in the 1960s, we can trace these processes. Gérard Assayag, for example, names French composer Pierre Babot, whose automatic composition is the result of the application of various types of rules on data. Hereby, following Assayag, the rules are specified by finite state automata or stochastic matrices. This enables Babot to generate counterpoint with harmonization and control, up to a certain extent, so to say, stylistic imitations. The described processes also relate to what is subsumed under the term algorithmic composition, as said, the term that Super uses to describe the processes in computer music. So, algorithmic composition stands for the structure of a work process which is not necessarily bound to a computer, which highlights Super explicitly and which maybe also be depicted by historic example that are named quite often as, for example, Mozart's Dice game. The term in music refers rather to processes that are based on preliminary mappings and procedures that can also be carried out by humans, technically. That, in a way, can also read between the line in John R. Maurer's Brief History of Algorithmic Composition from 1999, where Maurer states that, I quote, computers introduce incredibly new capacities available for algorithmic composition procedures. At the same time, when we look at the idea what algorithmic means in music, then we find it very close to the definition that we can find in informatics and computer science. In Thomas Corman's introduction to algorithms, algorithms are defined as computational procedures that take some value or set of values input and produces some value or set of values as output in a sequence of computational steps. And this, in a way, this, outlines quite well the idea that we also can find in music that embeds algorithms. All these developments are not only bound to purely compositional, genuinely compositional ideas, but also to the history of computer-assisted composition, as can be read from Gerard Assayac's outline of the history of computer-assisted composition, which Assayac presents in 1998. And the term itself refers to the French composition assistée par ordinateur, CAO, when naming most of the current developments and their predecessors. And hereby Assayac names examples that are both, as he puts it, automatic and algorithmic compositions. While the pioneering examples mentioned by Assayac are created between the 60s and the 70s, such as, for example, Barbon, Assayac states that after kind of a short period of oblivion, there has emerged something that can be seen as a modern computer-assisted composition since the mid of the 1980s. And this is marked by fundamental developments in technology, namely programming languages, protocols, digital processors, and also the availability, the broader availability of these devices to composers. Assayac describes his idea of what computer-assisted composition is, very general, as a prior formalization. A prior formalization makes it possible to program an automaton whose output is considered, without final improvement, as musical result. The basic argument is the division of the composition act in its technical and creative aspects. In other words, the idea is to provide a framework that helps the composer to concentrate only on the creative decisions and not bother with the technical processes. Those are maintained in a way by the predefined algorithms. At the same time, Assayac also points out the crucial challenge. It's not clear if it's possible to separate those two processes. From many analyses, we know that there exists a very strong mutual relationship between the development of the technologies and the artistic creation, which means that the genesis of the programs and systems is at the same time strongly influenced by the technical developments, but also by the composer's needs and wishes, or the musician's needs and wishes. So the question is, how can we kind of split that? What has, however, become very clear in this paragraph is Assayac's idea of computer-assisted composition. To him, computer-assisted composition means that we have programs or systems, tools, that help the composer to focus more on the artistic creation. And then the question is, how do these tools look like so that they help the composer in the way the composer needs it? Computer-assisted composition is, following Martin Supper, strongly connected, especially in the early years, to score generation. And Supper also states that this field can be called computer-aided composition, CAC, what you probably hear more often in the literature. In Supper's few remarks on algorithmic composition, he describes that within the various methods of algorithmic composition, the distinction between construction and resulting form, more precisely between the compositional idea and its realization in the score, and its auditory perception, is essential. Computer-aided algorithmic composing consists of constructing or selecting algorithms to generate a composition. These constructions are then evaluated and assessed according to whether the resultant form seems to work musically. So here we have this tiny limitation, or rather big limitation, that at the end of the process, there is this evaluation that's again done by the humans. So the question is, how can we, in a way, use the processes to then generate something that we won't touch afterwards? Or is that possible at all? We see that in this idea, the compositional process and also the compositional idea is not really separable from the use of the technology, and that we have also the assumption that the processes generating a composition can be or have to be made transparent if we want to have that transferred to the technical outlines or the technical tools. We're now looking at these different terms and definitions that emerged until the end of the 20th century, and you may have noticed that all these definitions I presented you have been created in the 90s. We can kind of identify 4 very broad directions that range between the idea of assisting tools and automated tools. And I tried to kind of outline this in a very short. We have composers programming algorithms that either help to compose or that are kind of creating the composition. And we have pre-programmed tools that either help to compose or that, in a way, by some adjustments of the composer, create the composition. All these approaches share that the concepts are based on a rather traditional view of the involvement of a composer who utilizes digital processes, even though the structure can be very, very different. While Barbeau, for example, aims at replacing, I quote, mystical passivity of the composer in the presence of the muse with a clearly thought out activity beating so-called inspiration by, for example, channeling chants into flowcharts, end of quote. Asayak depicts the image of a composer who programs an automaton that carries out the ideas the composer has. So there, the use of the tool is also kind of part of the creative process. Stephen Pope explicitly points out that it is important to differentiate between a composer who uses the computer models of for creating musical structures in the process of composition or organizing musical material, and on the other hand, the performance and production side that use the digital tools later on. And what I'm looking now onto, or also the examples that we will look at, only concentrate on the first part. So they only concentrate rather on the compositional side than on the production side, but you will see it shifts over time. In most approaches, so we assume that the computer helps the composer when we see that when someone says assisted composition. Pope, again, tries to put it or frame it, again, in the 1990s in a more precise way. So he writes, I quote, "Composers need software support for the refinement of incompletely specified ideas and the capture of abstract information early in the process of composition, and for the generation of score or the transition from composition to production or performance. A wide variety of processes involved in composition and the vague and abstract nature of high-level musical material both place special requirements on the design of software tools to support composers." That frames now both the challenges the composers face and the challenges all the people face that develop those kind of algorithms if it's not the composer. So far to the background and the background thoughts, and now let's look at some examples. One of the most important, so not so well-known computer in music was ELIAC 1. And that's a computer used by American composers Leigh Hiller and Leonard Isaacson to calculate the processes from which arose the ELIAC suite, which is a composition for string quartet. And this is the composition that is acknowledged as the first computer music composition. We can discuss this if that's true, but that's kind of as far as you look into the history books. ELIAC is Illinois automatic computer, was built in 1952. And the speciality of this computer was that there was another computer, Ortvac, that was kind of a twin computer, so they had software compatibility. The ELIAC computer was quite powerful, and it was used for more than 10 years and was replaced in 1962 by ELIAC 2. So the calculation processes that the two composers could process on this computer was quite complex, and they created a piece that is consisting of 4 movements, and each of the movement has another experiment. The first movement is based on 16 different rules in 3 categories and the 3 categories is what is allowable, what is forbidden, and what is required. And that included all the rules for simple polyphony. And within this rule-based structure, individual musical events were determined by chance procedures. And it resulted something that's kind of a simple cantus firmus melody in varying lengths. The second movement added to this first experiment different musical styles, and the third movement based on serial structures and techniques. A bit different is the fourth movement. That includes Markov chains, dependent random parameters to predict the next tone based on the previous ones. And Super now states that the first 3 experiments produced not just one single piece, but a whole class of compositions equivalent to the selected form. But the fourth movement generated new unpredictable forms. And this also kind of requested for the composers to change and interact their formal understanding of what they were expecting of the outcome. The claim of the composition is that the listener cannot distinguish whether the piece has been generated by means of algorithmic or traditional composition. And if this is applicable or not, you can try to judge it yourself. I brought a very brief example from the fourth movement because I think that's the most interesting one. It was recorded by Alex D'Annunzio. Unfortunately, I don't know the ensemble who played it. imagine how it continues. Another early representative who developed a program that generates score is the German composer Gottfried Michael König. And he developed two programs, Project 1 and Project 2, based on transferring serial composition techniques to computer processes. Project 1 started roughly around 65, and it integrates serial composition techniques to the user, generating a composition in 7 parts based on 4 parameters: Klangfarbe, rhythmic, pitch, and volume, for up to 9 instruments or instrument groups, which can be chosen by the composer at the beginning of the process. The 7 parts stand for 7 steps of regularity along which the parts are generated, and hereby it's possible to combine all these different parts and steps amongst each other. So if you use the program after selecting the composition technique and some of the parameters, you start the program, and then it can no longer be influenced. You have to wait until the result is produced, and then it's possible to shape duration and phrasing. The overall form consists of several single elements which are connected by implicit compositional strategies, and König updates the program several times. He wanted to show how detailed a description of a musical result can be done by using compositional abstract elements already before you start with the compositional process. He himself used it also for creating compositions. There resulted Project 1 version 1 from 65, 66, and Project 1 version 3 from 67 for small orchestra. Unfortunately, I didn't find a recording of those. Project 2 started in 67, and it contains the idea of extending these possibilities of Project 1. It offered 7 parameters: instrument, harmony, register, delay, or onset, you would say onset today, but not then, duration, pause, dynamic, and the composer who uses the program can insert as many numbers as wished. In addition, there exist several sub-programs which select data from these presets following different principles and put them together in a score. And the rules are set by the user in citing and combining all these possible selection criteria, or by predefining the order in which the parameters are calculated. König's idea was to create a program that is usable for others, not only for himself. He taught it also with his students. So the idea was to have terms that do not require mathematical or programming skills. He invented something called List-Tabellen-Ensemble-Prinzip, where different parameters, 5 out of 7, could be selected on a table-like structure to offer the program also to not technically advanced composers. And in 72, he also developed a program for sound synthesis, SSP, that transfers the values resulting from these Project 2 directly into sound. One of König's students at the Institute for Sonology was Serge Verstockt, and also he worked on formalization of compositional methods and developed Trans. Trans was a program with a graphical user interface for an Atari computer, and Verstockt created this project for himself. He developed some compositions, amongst others DMAP and DAC. But what is different to König, which was König's projects, which were definitely kind of a starting point for Verstockt to develop his program, is that he wanted to be more abstract and and this program was thought for being used in the context of electroacoustic music. The program can be rather defined as a music programming language than a program that is accessible to non-programming composers. And this again matches with the example Pope gives when listing computer-assisted composition programs. So Pope mentions, for example, Structured Sound Synthesis Project of the University of Toronto, or ARA Expert System. That's a Lisp-based programming language generated that generates Music 11 instrument definitions. And those two are also from the early 80s. So while on the one hand, the capacities of the digital processes became more and more powerful, on the other hand, the range of action of the composers started to change implicitly also by these offer and need to program. So the composers were now assumed to be able to interact directly with their programs and with the technology and have programming skills or at least knowledge of the structure and processes implemented. And this was kind of a parallel development to this idea that the composer has a technician that helps with the technology and does the programming. Karl-Heinz Essl developed his compose environment starting in the end of the 80s, in 88, also for the Atari ST computer. And this is a computer-aided composition programming environment. At the very beginning, it was written in Logo, later updated to Xlogo, and then again updated and to a Max extension. And following Essl, the idea was that the structure of Compose enhances the basic number of tasks of a computer program language by software modules. That means his major interest is to create a program for score listening, whose symbolic numeric appearance in the first instance translates score before being transferred in sound. Essl uses Compose to create Entsagung, and Entsagung is a piece that's written for an acoustic ensemble, flute, bass, clarinet, prepared piano and percussion, and live electronics. And the live electronics was at the very beginning processed by the IRCAM Musical Workstation, ESPW, where Essl collaborated with Serge Lemoton and where he also developed and worked on Compose. We can hear a short example from this composition recorded by Klangforum Wien. And as in the very beginning, not so much happens. And I really wanted to make you listen to the electronics as well. You see a part that's later than the score that you see. As said, Compose is the basis for the RTC library, real-time composition library, that is now a software library extension for Macs. And the composition, like Entsagung, is created using Compose, but the live electronics is created in a different process. So the formalization is now also processable in real time, or in a real-time environment at least. And this was one of the biggest changes going from Compose to the RTC library. The library is openly accessible and was also extended by several other composers who used this program or the library to create their compositions. In 2013, the library consisted of 164 so-called abstractions that are max patches that appear as objects, as well as 12 externals that were programmed directly in C. And most significant are hereby the tools that include random operations, rhythm, and harmony generators. Compositions using the R2C library were written, amongst others, by Gerhard Eckel, Orm Finnendahl, James McCarthy, Gary Lee Nelson, and Charles Baker, and they all contributed their extensions that they created with the library in the library. So their extensions are also integrated and accessible. Essel claims that this allows the user to concentrate more on the compositional issues as the development of the program structures take place at a very high level. And here we have the first time kind of this merge between a program that was initially developed as an assisting tool and now kind of transferred in a tool that is sitting in between assisting or helping the composer and integratable in as a tool that transports or carries out compositional ideas. The interest in creating computer-aided composition environments that are operable in real time, as the RTC library is, applies to many other programs as well. Open Music, Bach, all they got kind of extensions operating in real time, and they also the capabilities for musical notation and symbolic symbolic processing with real-time environments kind of merge or are provided. This includes the development of real-time score generation, as well as the real-time transfer of MIDI to sound, as feasible today, real-time sound synthesis. That's due to the processor, a rather new development, let's say. And this leads to a new merge, and this is that we shift a bit more towards this idea of instrument, or also new ways to embed this idea of what the computer helps. In a way, here the question of this romantic concept of composition starts to blur a bit, because the generative systems that appear, especially in the 21st century, they are no longer clearly distinguishable for one specific help or one specific task to be carried out. And so the next examples that I brought are in a way sitting in between these concepts, integrating different ideas, but still kind of keep the idea of helping. The Lifestyle project by Kingsley Ash and Nikos Stravopoulos is, for example, based at the intersection between composed environment and real-time score synthesis. Here, notation is generated based on simulated growth processes that are mapped to algorithms that transform the emerging growth structure into score for a string quartet. That means that the conductor has a blank screen and can put on a touch screen growth cells. These structures grow in a certain way and are in real time mapped to score that is displayed to a string quartet, and the string quartet plays this again in real time. The conductor can, in a way, control the system by placing or erasing these growth cell groups, but how the cell grows develops, that's out of the control of the composer, of the conductor. That's based in the composed system. And That's how a setup looks like. And we can hear a short excerpt that was a performance at the ICMC in Huddersfield in 2011. So I think the system is clear. The each performance is different because the conductor can place the cells, and there are four different growth systems, can place it every time in a different way, but the structure, how it's transferred, is always the same. A different idea of transferring the emerging score into sound can be seen in other very famous project, which is George Lewis' Voyager. Here, not musicians play the emerging score, but a MIDI-driven piano. That means that MIDI is generated and in real time transferred to a MIDI piano that plays what is generated. And the idea here is to create a co-improvisation between a human improviser and the program Voyager. The program has two parts. One is listening analysis. So the pitch of the second piano is tracked, is mapped into MIDI. Then the program learns from what is input from the input provided and creates kind of response along a set of rules. And in addition, it has a so-called set phrase behavior it combines these learned rules with a predefined rule set that is completely independent from what is going on at the other piano. And the created response is thus, in a way, a response to the other improviser, but also some genuinely programmed idea of George Lewis that is implemented in this program. So the program is not one compositional producer, or is also not a help to produce a composition, but it incorporates all these ideas of how improvisation could be formalized by a program. And the piano, in a way, is presented, the second piano, the M2 piano, Voyager, is presented as a co-musician. And this idea of having an automatic co-improviser that is based on a program is still very, very appealing. And this is a performance that was recorded in 2020 at Haus der Kulturen der Welt in Berlin at the Festival Disappearance of Music and the second prepared piano is played by Magda Meyers, and we can hear some music from this. Unfortunately, the example is really, really quiet. So maybe it's on YouTube. You can listen to the full performance there. Interesting is also the staging of this presentation. So the piano is really presented as a co-musician and also placed with the same presence on stage. And this idea is also of a co-musician is also taken by a completely different approach that is Mason by Kivan Tata and Philippe Pasquier. Here, MASM is the acronym for musical agent based on self-organizing maps, and it's designed for experimental music and free improvisation, with the idea to present an agent that can play in real time with human musicians. The architecture is hybrid. The architecture of MASM is hybrid, including a combination of several different agent systems that are combined in a sub-layered structure. And the idea behind it is the development of computational creativity, also called creative computing or artificial creativity. And that's an area that's located in the field of artificial intelligence research and aims to develop and implement processes that produce both that produce and evaluate novel outcomes and generate an output that, if it was produced by a human, it would be considered creative. Hereby, computational creativity stands out from other problem-solving AI processes, and Pasquier mentions that very explicit. There is no unique, identifiable best or optimal solution to achieve this, because there are no fixed rational rules that can evaluate the process or the results. The musical meta creation covers a very wide spectrum, from purely generative to a variety of interactive systems that have different degrees of autonomy. And the interesting part in MASM is that here Pasquier and Tata combine corpus-based and algorithmic approaches to machine learning in one system. One of the projects where MASM was used is the project Revive, that was created by Tata Pasquier and Rémi Sioux, and they started with this idea of creating an artificial intelligence trained by the oeuvre of composers that already have passed, and to create it in a way that they can play performances as if the artificial representative is the composer they can play with. So is not this idea that we can see by Pope that a algorithm kind of writes new compositions, and then you can kind of compare the outcome of the composition with the pieces that you use as a corpus for the training. But here really the idea is to do that in real time and to act as if. The result was a bit different. So they tried with different corpora, and they also tried with training it by just one composer or two composers. But they chose that kind of a mix. The training data also changed due to the performances, and it resulted in improvisation-based live audiovisual performance employing MASM as an artificial musician on stage together with the other three performers, but is not represented with a physical representation. So there is no extra object on stage. Nevertheless, the performance consists of 4 sounding units, which are the three musical agents: two humans, one artificial, and kind of a background sound, and the three main performer, two human, one agent, are represented by visual appearance in an audiovisual context, and the sounds are also distributed spatially by IRCAM's PET Max library, in case that's possible for the performance room, so that for the audience, it also seems as if there would be three sound sources to kind of distinguish between the performer. The major emphasis is to have a sonic result that could be also created by three humans. And the musical agents communicate by what they call listening. Listening means that on the one hand, it listens to the performer, so that there is a tracking of the resulting sound that is reinserted in the agent system, but also listening to what they call music that has already occurred, means the trainings data. There is a corpus where that creates the basic set for BASEM to start with. I brought you a very short excerpt from a performance at MUTEC Montreal in 2018 at the Stratosphere series. And no. The visualization that you saw is a quite complex mapping of different visual cues to sound, so that kind of the audience can follow also visually the audio. And the three people, the third person that you saw on stage, that's Remisiu. He did the visuals, basically, so you couldn't hear him. Today, many computer programs have been designed and developed by humans to serve artistic needs, either to support humans or to seemingly be independent actors. And only few examples of these systems produce an output that was not curated after the genesis. And these two live performances were one of the few examples where there is no chance to do kind of a revision afterwards. One of the first projects that requested to hand in music without final revision in a fixed sense, so generating fixed music, was the AI song contest. That was launched the first time, 2020, by Google Magenta. And here the requirement was that the music had to be fully generated by employing AI systems, and it wasn't the developer or the musician were not allowed to judge or to process the result. And the evaluation of the winner or the selection of the winner was not only based on the outcome, on the musical outcome, but also on the processes. So they had to hand in also the processes that they used for creating this music. This year's edition, now organized by Stitching ASC, how they call it, so they founded an organization that only organizes AI song contests, softened this idea a bit, announcing the contest as, I quote, an international competition showcasing the creative potential of human AI co-creativity in the songwriting process. And this shift is something that you also can see in the previous example. The idea of MESM was working towards a co-creation rather than kind of handing over an automatic system that works just by itself. The winner of this year's AI Song Contest was announced 10 days ago. So I thought it might be interesting for you to hear how this year's winner's song sounds like. It was created by Synthetic Beat Brigade, and it's called How Would You Touch Me? The song is about the unattainable love between human and AI, and and the different elements of the song were created along a very AI-centered process. The developer team, that were 8 people with very different backgrounds from music to programming, claimed that they decide to use AI for every step of the production process and to use an analytic approach rather than trusting their instincts, whatever that means. For example, they chose that the main melody should be informed by successful examples. So they chose an analysis of all Eurovision songs from 2010 to 2019. They found that the most were love songs, but also songs about loneliness, regret, and heartache were quite popular. They found that it always got slower and slower, so not too fast. The song's topic was, and also the text, the lyrics were generated by the second GPT-2, the open source GPT-2 model, and had been retrained with lyrics to generate lyrics for the song. And they also reinserted the lyrics in the model again to get new lyrics. The music and the vocals were created by using various AI tools, and the overall idea was really to interact with the AI in a co-creation process. So whatever they did, they claim to prove by AI. In a way, that's not completely the truth, because they also claim that it was very important for them to have creative, and catchy rhythms and lyrics, and especially emphasis on the specific rhythmic scheme. So there was a selection process that was kind of on a human decision of creativity to select what they fed and what they also requested from the AI tools they used. And this song, I would say we listen a bit from the beginning. It's quite long, so you may have to finish this at home.
How would you touch me? If you had a heart, would you hold me tight? How would you touch me? And never let me fall apart.
I was created to understand love, but could never feel it like a human does. My circuits process, data they churn. For the warmth of true love, I deeply yearn. Can love be real between us? Or is it just an illusion?
How would you touch me? If you had a heart, would you hold me tight? And never let me fall apart. You don't have skin, but you do have a mind. You're not from this world, but to me, you're one of a kind. I'll never know how it feels until we start this fusion. How would you touch me?
This, in a way, brings us back to the initial question of what does it practically mean to integrate complex algorithms or also generative processes in music composition and production. While we see that still technical developments drive these creative ideas quite a lot. For example, last year's AI Song Contest winner was Enter Demons and Goods from the Bangkok-born Yaboy Hanoi, and he also and a selling point for his production was that he used audio AI, despite the symbolic AI that was quite common until then. Because with the audio AI, it was possible also to have harmonic systems and pitch classes that are out of the Western system. On the other hand, we see that between creation and creator, there is still a broad range of, let's say, negotiation on what is possible and what they want to have developed and what they also want to use. The automated processes seem to have become an integral part of today's music production, and in a way also within the development, but we also see that they are far from really working alone, independent from any input or creative vision of humans. And I think especially in this development of the AI Music Song Contest, you can see that quite well, because it became quite soon clear that it was always only possible to generate one part of the song, but not the entire song at once. So all these different parts, and be it either the text and the voices and the harmonics and the rhythms, they all have been generated in parts and then kind of put together. But it was not possible to write one big algorithm that could just produce the full song with all the single kind of ingredients, if you want to. Also, the brief look into history reveals that the implementation of automated processes is not new at all and can be traced back really to the very beginning of the electric and digital processing. The possibilities of what can be handed over to the computational processes has changed, and also the range and the complexity to what extent human composers can influence these algorithms. And in a way, for me, sometimes a new question appears. Because in computer-assisted composition, as well in algorithmic composition, it is assumed that for sure the computer helps the human. But when we talk about music and AI, we see that the processes in a way suggest that the object is independent, but they rely on the knowledge of the humans and on a very specifically formalized knowledge of humans. So in a way, humans assist systems to be able to produce music. And if you would do the full circle, we could also say humans help systems to produce something to help the humans. This shows that digital tools, contents, and music creation is still very closely interlinked, and that the tools that we have mirror both the state of the art and the artistic interest, but also the state of the technical development. Generative processes and algorithms, however, are not as independent as they might seem from far. This ties in with the question of the relationship between humans and music, but also to very general concerns. As I said, do algorithms take over? Maybe not as soon as we fear that could happen, at least not for music. Or is everything only developing towards a more and more specialized system of automated and computer-assisted composition? Well, I think that so far, generative processes in music are both developed for automatic sound creation and creative use by composers and musicians. And in a way, all these new complex forms of using these technologies open up a wide range for us musicologists to work on new forms of music and also to face these new challenges on a totally different level. And this, in a way, makes all these well-known questions very, very new and very, very exciting. So I think there are quite interesting times ahead. Thank you very much.